research study that we will presenting is entitled Solar Energy, Power Source of Charging Station at CEA Main Campus 2. We want to thank Dr. Craig Refugio for guiding us in making this research paper.
We would also want to thank Dr. Florence Gil-Callis for showing great support in letting us use her dissertation for reference.
Chapter 1. Rationale of the study. Access to electricity is one of the major factors that impose the socio-economic of a country. Load management for electricity is a crying need to develop the sector a sustainable manner. Only it can provide more benefit to our citizens and environment. Harnessing the sun's energy is within our grasp, and for developing countries, this is a golden opportunity. Solar power is an increasing market for more developed countries, which can benefit from less electric over time. It is also good for the environment because it replaces the traditional and in effect harmful methods of energy production. There are other renewable energy sources besides solar, but it is especially practically for sunny areas which have less wind and water resources. Because of the extensive research being conducted in this field, solar panels are developing into more efficient models than ever. The higher the competition level between manufacturers allows the cheaper prices as well. Installing solar-powered charging station on college campuses is a phenomenal idea for students and colleges. It raises solar awareness and provides students and faculty with a method to charge their mobile devices conveniently and free of charge. The charging station can power electronic devices such as cell phones, laptops, and tablets, typically items that the student use. Also, it will encourage students to take advantage of the outdoor campus. Many colleges are adapting this new technology to their campuses. Besides the fact that colleges like to keep up with their counterparts, by investing in this technology, they will enable a path to sustainability. Success with solar charging station could lead college to go for further scale. Renewable energy investments such as photovoltaic on rooftops and EV charging stations. Reason for choosing solar energy are also indicated by the growing numbers of projects conducted by various organizations and governments. In the past couple years, advancements in technology put devices in our pockets that we could have been dreamed of years ago. However, these devices often have drawbacks. One of the most pressing issues with phones, tablets, laptops, PC power, and etc. We have not yet been able to develop efficiency of our devices. In fact, many laptops can drain standard battery from a full charge in a matter of a couple hours. This team is proposing a solution that provides power to charge device using power generated from solar energy.
Statement of the problem. Many of the outlets in CEA buildings are not functional. Some students and professors cannot use their devices for educational purposes because their battery is dying. Harnessing solar energy as a source of electricity for charging stations to be implemented in CEA would mean making everyone to be untroubled with charging issues. Thus, supply-side operation is needed to help power consumption to be minimized. Particularly, the study aims to answer the following questions. 1. What are the dimensions of the solar panels to be used? 2. What are the dimensions of the solar-powered charging station that will be mounted in CEA building? 3. Where will be the best location to install the solar power charging station in CEA building? 4. What is the estimated cost for installing 2 solar-powered charging stations? 5. What is the average monthly power supply a station can produce? 6. How much power can we save in a month in terms of kilowatts?
Significance of the study. The result of this study will be beneficial to the engineering students of Negros Oriental State University, NORSO, the environment, and the other researchers. The environment. Solar energy is a renewable energy that can help for our environment. Solar energy are clean sources of energy that have much lower environment impact than conventional energy technologies. Solar energy system offers significant environment benefits in comparison to the conventional energy sources. Thus, they greatly contribute to the sustainable development of human activities. At times, however, the wide-scale development of such system has to face potential negative environment implications. The students will benefit from this charging station of CEA main campus too, as it would allow them to capability to learn more effectively. Many students record lectures or take notes on their mobile devices such as smartphones, tablets, and laptops. Keeping these devices charged for a full day at school is a challenge. Having free power at their fingertips will enhance their overall learning experiences. Researchers. This study benefit the researchers from learning about renewable energy, as these charging stations provide a hands-on learning experiences. The educational component encourages them to think beyond current application for renewable energy to inspire the generation of students. This will also useful to our researchers who are studying on topics related to solar energy. The study will add to the much needed related literature review, and the study strengthened conceptual and theoretical framework of the proposed study.
Scope and limitation of the study. The study will only cover the CEA building of Negros Oriental State University. For most of the students of engineering department uses the building's convenience outlet to charge their gadgets and devices as frequently as every day. The amount of electricity that can be generated, assuming all throughout the week, the solar panels are exposed to the maximum availability of sunlight during daytime. The amount of stored electricity that can be used during nighttime and or when during emergencies. The amount of excess electricity that can be supplied to the building's power system when the battery of the stations are fully charged and there is no one charging at the station is excluded from this study. This matter can be included in the recommendation. The estimated cost per materials to be used when building the stations, assuming that the labor is done by volunteer students. The materials includes the whole part of a photovoltaic system which we can buy on electrical supply stores.
Definition of terms. In order to have a common understanding on the words used in this particular research, the following terms are defined as follows.
So first, ampere R. An ampere R or amp R, which has the symbol A times H or AH, often also officially denoted as AH, is a unit of electric charge having dimensions of electric current multiplied by time equal to the charge transferred by a steady current of 1 ampere flowing for 1 hour or 3,600 coulombs.
Next, discharge. Discharging is the opposite of charging. When you charge some electric component, such as battery, you are storing potential electric energy in it. When you discharge the battery, You are reversing the charging process and using the potential electric energy to drive other electric components.
Electricity, the set of physical phenomena associated with the presence and flow of electric charge. Electricity gives a wide variety of well-known effects such as lightning, static electricity, electromagnetic induction, and electric current. The electricity is the source power that can be used to energize the lighting loads, air conditioning units, and other plug loads.
Renewable energy, generally defined as energy that is collected from resources which are naturally replenished on a human timescale, such as sunlight, wind, rain, tides, waves, and geothermal heat. Renewable energy like the solar energy is the study will provide electricity to NORSO in combination with electricity from utility company.
Photovoltaic, the conversion of light into electricity using semiconducting materials that inhibit the photovoltaic effect, a phenomenon studied in physics, photochemistry, and electrochemistry. The photovoltaic effect is commercially utilized for electricity generation and as photosensors.
Solar energy, radiant light and heat from the sun that is harnessed using a range or ever-evolving technologies such as solar heating, photovoltaics, solar thermal energy, solar architecture, and artificial photosynthesis, or this simply means energy.
Solar panel, an assembly of photovoltaic cells mounted in a framework for installation. Solar panels use sunlight as a source of energy to generate direct current electricity. A collection of PV modules is called a PV panel, and a system of panels is an array. Arrays of a photovoltaic system supply solar electricity to electrical equipment.
Theoretical framework of the study. This study is based on theory that light could produce electrical charges when exposed to the surface of certain materials. In 1839, French physicist Edmond Becquerel discovered the photovoltaic effect while experimenting with a cell made of a metal electrodes in a conducting solution. He noted that the cell produced more electricity when it was exposed to light. Edmond Becquerel, the main behind the solar panels. A photovoltaic PV cell, commonly called a solar cell, is a non-mechanical device that converts sunlight directly into electricity. Some PV cells can convert artificial light into electricity. A solar panel works by allowing photons or particles of light to knock electrons free from atoms, generating a flow of electricity. Solar panels actually comprise many smaller units called photovoltaic cells as shown in the figure below. Close-up of a PV cell. So this is the intersection of coating. This one. Transparent adhesive. This one is in the upper of the anti-reflection coating. Then the last is the cover glass. Front contact. This one. Sunlight. So to the sunlight. Then current. It will create light on back. This one is the back contact. N-type semiconductor. P-type semiconductor. This one below the N-type. So close up. The red one is called the N-type semiconductor. This front contact. This is the which will the current flow. This one. So as you can see, these are the electrons the yellow one, this one in the middle, this is the p-n junction. Then below the p-n junction is the p-type semiconductor. The last one is the back contact. This is the photovoltaic cell.
Conceptual framework of the study. This study is based on the concept of harnessing solar energy to produce off-grid daily electricity supply. Implementing solar-powered energy system to CEA building at Norso Main Campus 2 enables the university to consume small power-consuming devices from off-grid power system. The university is upgrading. New buildings are constructed, thus another infrastructure to be supplied with power. The conceptual framework of this study will be shown in the figure below. This will greatly help the university to answer the demand of consumption of electricity from the primary source. It would be a great opportunity for the people living in the Philippines to harness solar energy, for its location lies near the equator, where the light energy from the sun is very exposed. Currently, the university is supplied by Noreco 2 to fulfill the demand of electricity to the campus. During daytime, when batteries are fully charged, the excess power from the PV supply system can be used by neighboring infrastructure in MC2 of North 2. During daytime, when batteries are fully charged, the excess power from the PV supply system can be used by neighboring infrastructure in MC2 of Norsu. With this kind of system, Norsu Main Campus 2 can generate savings after the return of investment, or ROI. Adapting to this kind of innovation can contribute help to our environment. Harnessing solar energy from the sun to produce electricity reduces the use of fuel to power the plant, which are also great contributor of pollution in the air and is harmful for the people, animals, and the environment.
Review of related literature and studies. There are many literatures we can use on in relation to the study of solar powered technologies. Naturally renewable energy resources such as sunlight, wind, rain, tides, and geothermal heat are naturally replenished. According to the study, it's more sun in the Philippines. Facts and figures on solar energy in the Philippine Project Development Program (PDP) Southeast Asia by DOC. Harnessing solar power is one way to decrease dependence on these increasing and volatile prices of fossil fuels. This bulk of the country's supplies of crude and finished petroleum products come from the Middle East. As seen in the past, conflict in various parts of the Middle East adversely affect the local fuel prices. Dwindling oil supply even threatens economic stability, as huge oil demand from countries like China, India, and the United States siphon the bulk of oil reserves. Being a small buyer in the Philippines is a huge disadvantage both in terms of access and price, but with more renewable energy source in place, including solar, the Philippines becomes less exposed to external risk and less dependent on foreign oil. Hedging for the future reduces the country's exposure to geopolitical conflicts, as sunlight is accessible to all but rich and poor countries. In other section of the same study, solar energy makes sense for consumers. Solar energy provides us immediate solution to the country's energy issue. It is the only cost-effective technology that can be installed and commissioned as short as a few days to a few months. According to the EPIA and 1MW, solar power plant can be installed in a short or 6 weeks. while smaller systems only take a day to install. A 70 megawatts solar power plant in Italy was built and commissioned in just 9 months, less than a third of the time it took to construct the power of a coal-fired generation facility. Areas such as Visayas and Mindanao, which are already experiencing rotating brownouts, cannot wait 3 to 5 years before adequate power supply can be made available. According to Arnulf GW, solar energy system can also sustain even if there is an economic disaster. The photovoltaic industrial production again increased by more than 50% and reached a worldwide production volume of 11.5 GP of photovoltaic modules in year 2009. On an article posted by Asian Briefing, it was stated that current electricity costs in the Philippines are the highest in Asia, including Japan. This makes solar power a much cheaper and economically more advantageous option in the Philippines. The Philippines is a country of 102 million people and is a relatively fast-growing Asian economy, and it is anticipated that 7,000 megawatts of power generation will be added to the next 5 years. An estimated 16 million people are off the grid with regards to the current electricity supply, and this includes approximately 6,000 schools. This demonstrates the potential for supplying solar power to the Philippines. Residents in off-grid areas are beginning to arrange the finance to purchase solar panels, batteries, and etc. The Philippine government has also committed to a 70% reduction in carbon emission by 2030 and has a 15.3 gigawatts renewable energy target, that's thus encouraging a large increase in solar power as an energy source. The sun creates two main types of energy, light and heat, that we can harness for many activities ranging from photosynthesis in plants to creating electricity with photovoltaic cells to heating water and food. With the help of solar panels, harnessing solar energy becomes easier. For example, in US, most of the users of solar energy are water heating systems. Solar heating, solar lighting, solar ventilation, portable solar, solar transportation, and other solar electricity. In United States, the applicants of solar electricity gained a lot of momentum in recent years. As solar panel costs decline, the more power become aware to the financial and environmental benefits of solar energy. Solar electricity is becoming increasingly accessible, while still a very small percentage of the electricity generated in the US, 1.9% in 2017. Solar electricity is growing rapidly, almost tripling over 3 years period and up to 40+% versus 2016, according to the US Energy Information Administration. A distributed solar PV system is typically installed on the rooftops of homes or businesses. This solar power system generates electricity to offset the property owner's usage and send any excess production to the electricity grid. These solar batteries function to store energy produced by your solar panels for later use. In some cases, solar batteries have their own inverter and offer integrated energy conversion. The higher your battery's capacity, the more solar energy it can store. When install a solar battery as part of your solar panel system, you are able to store excess solar electricity at your home instead of sending it back to the grid. If your solar panels are producing more electricity than you need, the excess energy goes toward charging the battery. Later, when your solar panels aren't producing electricity, you can draw down the energy you stored earlier in your battery for night use. You'll only send electricity back to the grid when your battery is fully charged, and you'll only draw electricity from a grid when your battery is depleted. What this means in practical terms, in the homes with solar plus storage can store exists solar power on site for use later when the sun isn't shining. As a bonus, since solar batteries store energy at your home, they're also offered short-term backup power in the event that there's a power outage in your area. There are many inventions called universal solar power charger nowadays. A universal charger was designed to charge the battery of an electronic gadget by using a renewable source of the solar energy. The devices harness that every present solar energy by using solar panels and converts that energy into a direct current and then store it in a battery storage. The storage battery supplies 12 volts, 2.4 amperes, which is sufficient to operate the cigarette jack charger. The cigarette jack charger regulates the voltage coming from the battery storage and then charges the battery of the electronic gadget. But according to Raquel G. and many solar power chargers are too funny to make much of a dent in refilling a phone or tablet's battery life. Either their capacity is too low, their output is too weak, or both depending on the manufacturer. Countless of related literature and studies are there to be used in the relation of harnessing solar energy. The advantage in using solar energy is in fact plenty. Our country is a candidate of upgrading our power system according to DOC. Installation of solar product is an advantage for our country's geographical position. It also has a lot of room to take advantage of the investment and jobs that can be created by future solar power installation, as well as look forward to cheaper and cleaner power that is not affected by geopolitics. Reducing fuel consumption makes the solar economically viable electricity source for Philippines consumers and industries. It is the right time that NORSO adapt to this advancement of technology. As we harness the solar energy, we can contribute help to our mother nature. We can help lessen the pollution from burning fuels and which releases greenhouse gases such as carbon dioxide, nitrogen oxide, sulfur dioxide, smoke, and other pollutions. Our initiation to these technological advancements will greatly help our environment hazardous gas-free air.
Research methodology. The schematic design of the study is shown in the figure below. So figure 3, but this is the flowchart of the research design. So from the start, the first event is to know the building's profile of location where to install the panel system. Then defining the sizes and numbers of solar panels. Then defining the sizes of batteries. Then appropriate inverter. And then if the power grid is connected on the installed solar powered system, then you have to connect it into the charge controller. Then if no, then you just connect it directly to the outlet, and then the end. Identifying what part of the building which provides the maximum sunlight is the most concerned factor in the study. Upon surveying the building, the strategic spot of the building was determined. The rooftop of the building is the location that fits the best for the solar panels to harness solar energy. The rooftop of the building is the location that fits the best for the solar panels to harness solar energy. There is less interruption of the system is installed in the rooftop of the building. The building is taller than those trees around it, enabling the system to absorb sunlight, especially during peak sun hours in the afternoon. Another aspect to consider are the following parameters: the weight, dimensions, and position and orientation of all the materials within the PV system. The weight of the whole system is guaranteed not to be heavy enough to cause cracks or damage to the structure of the building. The dimension is also minimized that it would not bother anyone or be an obstruction on the rooftop. The efficiency of the system depends on the positioning and orientation of the solar panels. Orienting it to the right direction with side angle of inclination is the key to harness solar energy at its optimum state. After identifying all the parameters of the materials for the PV system, the system parameters as a whole is then computed. The parameter of the whole system is needed for designing PV system. The design of the system is also considered that it is safe to use, user-friendly, and strong enough to withstand any weather. The system is supposed to perform at its optimal performance, providing electricity without causing any hazard to the user. After all the needed data were measured and calculated, the PV generating system is designed as shown in the figure below. So from the start, first event is to determine the best location for the solar panel. Then there's a question: is it possible for the building to install this additional system? If yes, then calculate the dimension of the solar panels. If no, we will find another spot and then proceed to calculate the dimensions of the solar system. Then design the system to be installed, and the end. That is the figure 4, flowchart of solar electricity generation. As the size of the PV modules were determined, it is now possible to compute how much power can be produced by the solar panels with the use of this formula. So, P in watt is equal to the N sub M times P sub R, where P is the power produced, which is in the units of watts. N sub M is the number of PV modules. P sub R is equal to the power rating per modules, which is in units of watts. For determining energy produced, kilowatt per day is equal to the N sub M times P sub R times 5 hours per day, where Nm or N sub M is equal to the number of PV modules, P sub R is equal to the power rating of the modules in units of watts. 5 hours is the sun's peak hour in the Philippines. It is assumed that it is the maximum availability of the sunlight that which the solar panels are to be exposed. So, inverters are used in PV generating system to convert DC currents to AC currents. Appropriate inverters should be considered to enable the system's maximum capability to process the harvested solar energy. As the general rule of thumb, the size of your inverter should be similar to the DC rating of your solar panel system. A solar system is also known as solar regulator. Regulates the battery charging process to ensure battery is correctly charged. The appropriate charge controller rating in a solar panel system should be 10 to 20% of the battery's ampere per hour rating or AH rating for identifying return of investments in terms of years or the ROI. So ROI is equal to the total cost of the project over cost of energy produced.
And that's all for our research presentation.
Thank you.